Welcome to this video. In this episode we will try to look inside this oscilloscope and we will try to repair it. Its model is the circuit mate TI-3051. It's an OLED analog scope. It has a maximum frequency of 200 kHz. We have here the input, the main input, no BNC yet. For OLED scope, we have here the triggering knob. We have here the position, vertical position and horizontal position. We have the focus, and here the main switch. It works with as the power switch and it can vary the intensity. We will see in the back. We have a marker for polarity. This is for trace rotate. They may rotate the entire tube. Marker input, ground. This is the marker gain. We will see now what's inside this scope. We have here the vacuum tube, cathode dry tube. Here we have the main transformer. It has the multiple winding at the output. We have here the main circuit. It's an OLED circuit with single side PCB. Here all the potentiometer. Here we have a small PCB. Maybe it's for the high voltage part. I will remove those screws and we will look inside. A small washer. Of course, you mustn't touch this side if the scope is powered or after turning it off with this little bit of time. We must wait until those capacitors discharge. This we have those two capacitors, three capacitors. They are 1000 volt, 0.1 microfarad. This one is 0.1 microfarad, 1000 volt. It's hand rated here. Maybe it was serviced before. One. This one 0.1 microfarad, 1600 volt. This arrow is maybe for the plus side and this is the negative side. 100 nanofarad, this one. and this one. They are marked 1, 2 and 3. 1, 2 and 3. Maybe it was serviced before me. We have here was serviced, yes. We have here 470 kilo ohm tow in series. We have here the main transformer. The fuse is okay. Fuse is okay. Maybe we will test before putting this scope power in this scope. We will test those resistors if they are okay. So here we must found about 800 kilo ohm. Tow resistor in series 900 kilo ohm. Okay. And here we have tow in series about 3 mega ohm in totally. Here we have 1 mega ohm and here we have another 1 mega ohm. So this, all those resistor value is about 3 mega ohm. About 3 mega ohm. When I touch this side and this side, I false the reading. So in order to measure high value resistance, we mustn't touch them because we have about 2.5 mega ohm. Our body can introduce an error in the reading. Here we have, we must touch only the PCB, 2.8 mega ohm. This is the ground, what they said here, 41, 42. I will, of course, I will put the PCB. We will power this scope and we will see if we have a trace. This is the ground, and this one. So this is connected to the ground, this part is connected to the ground, and this part also. This one connect the shielding for the CRT. We will power the scope and we will see. It draws about 1 watt before, no, 0 watt. Now I will power. It draw about 10 watt. 10 watt. We have here now the LED, red LED. But we have no trace. We will test about the position. Now sweep and now trace. Now I will wait until the capacitor discharges and we will investigate the PCB. Before servicing this scope, I will see if the filament of the CRT is okay, because if the filament is burned, we have no chance to repair this oscilloscope. I will search to find I haven't the reference of this tip. This one, because only the two pins of the filament are connected, or those are for the plate for moving the beam. Here we can measure the resistance, so we will mark those two pins. Those are for the heating element. We will put a mark between them. And we will see if we have a 6.3 volt. I marked here the pins to the heater filament. Now I will mark their correspondence in the socket. Now I have the two pins here. We will trace this for pin 1 and pin 14. So pin 1 and pin 14 are for the heating element. we will test here. We will find the winding, the resistance of the winding for this heater. 1.5. This is promising. We will see if we will maybe solder here 2 wire, and we will see if we have 6.3 volt for the heating element. I didn't find the schematic for this scope. I will of course use a shaper multimeter. With high voltage we can damage easily the multimeter. We have alternative current here. We will put the leads here. We will warp those cable here. And this one now I will power the scope, and I will see if we have some voltage here. Now I will power the scope. I will power. It's okay. We have 7 volt here for the heating element, alternative current. And we haven't yet a trace, so it may be a problem of the accelerating voltage. Because the resistance of the heating filament is okay, and we have heating voltage, I will remove these ladies and we will see if we have here our voltage are okay or not. Here we have a schematic of the CRT tube. We have here the filament, here the cathode, the geared, and the anode. And here we have the deflating plate, the Y plate and the X plate. So what we need here is the accelerating voltage, because we have now electron beam. I found here minus 1200 volt. I will measure this voltage in order to see if we have an issue with the high voltage section. I will use this meter. It's analog meter from Matrix. It has 1500 max voltage. So we have a negative voltage, so we put the positive to the chassis, and we will power the scope, and we will see. Now I will power the scope. We have high voltage here. We can see that we have here about 1200. It's okay. We have here 1300 and maybe 1300. So our high voltage is okay. Found here plus 150 volt and 170. I will see if they are okay or not. Those power rail, we build the voltage. So here we have 170 and we must find 150, and here we have 200 plus 170, so we have a problem here. I paused the video and disconnected those leads. They are for the horizontal amplifier. I disconnect here the pin number 12 and the pin number 13. They are connected to the horizontal player, and when I power the scope, I get the trace finally. Here we can see we have a point here. So the problem was with the voltage on the deflection plate, on the horizontal deflection plate. So this knob here for timing has now friction. I will test now the vertical amplifier. So at the end of this part we found a trace finally. We have here a little spot. We can see that we have the vertical amplifier work. We can adjust the focus. The position. Here we can see that we have our vertical amplifier working. In the next part I will try to repair the horizontal section. Thanks for watching, and for the next video.